Hello, I am Hanan Tasnim Bintino, alias Muhammad No.
Hello, I am Najia Farhana. My student ID is 2024288304.
My name is Nur Nisa binti Badi.
Hi, I am Vina Navratila and my student ID is 202-444-7954.
Volumetric analysis is defined as the preparations, storage, and exact measurements of chemical volumes for analytical purposes. Although this knowledge is frequently applied in our laboratory experiments, have you ever wondered why it is so emphasized in the classroom and in our practical work? Well, this branch of analytical chemistry is crucial in industrial settings as it determines the exact concentrations and volumes of substances, which is essential for safe usage and consumption of products. In this video, our group will be explaining how volumetric analysis is fundamental in the food industry. To illustrate this real-life application, we will be showing an example of how acid-base titration can be used to evaluate the total acidity of various homemade fruit vinegar based on an article published by Fermented et al. In 2025.
So I'm going to explain based on the theory. In this experiment, we use acid-base titration. Acid-base titration is a type of volumetric analysis used to determine the concentration of an acid or base by reacting it with a standard solution of known concentration. The method is based on a neutralization reaction between an acid and a base until the equivalence point is reached. In this study, acid-base titration was used to determine the total acidity of homemade vinegar prepared from pineapple, apple, pear, and orange. The acidity of vinegar is mainly due to the presence of organic acids, particularly acetic acid, which is produced during the fermentation process. The acidity level is an important quality parameter because it affects the taste, preservation, microbiological stability, and overall quality of vinegar. The principle of the method, the organic acids present in vinegar react with sodium hydroxide, a standard alkaline solution. The amount of sodium hydroxide required to neutralize the acids is proportional to the acidity of the vinegar sample. Moving on to the methodology, preparation of homemade fruit vinegar. 4 homemade fruit vinegar samples were prepared using pineapple, apple, pear, and orange fruits. The fruits were washed thoroughly under running water and cut into small cubes to accelerate the fermentation process. The fruit pieces were placed into glass jars and submerged in water until completely covered. Approximately 1 teaspoon of sugar was added to each fruit sample and mixed thoroughly. The jars were then covered with a clean cloth and secured with rubber bands to allow air exchange while preventing contamination. The samples were left to undergo natural fermentation, during which microorganisms converted sugars into alcohol and subsequently into organic acids, producing vinegar. Determination of total acidity. The total acidity of the homemade fruit vinegar samples was determined using the acid-base titration method. Sample preparation. Approximately 10 grams of vinegar sample was weighed. The sample was then diluted with distilled water to a final volume of 250 ml. The solution was mixed thoroughly to obtain a homogeneous sample. A 25 ml portion of the diluted sample was then transferred into a 100 ml Erlenmeyer flask. Titration procedure. 3 to 5 drops of phenolphthalein indicator were added to the sample solution. A beret was filled with 0.1 normality sodium hydroxide. The vinegar sample was titrated with sodium hydroxide while swirling continuously. Titration was then continued until a stable light pink color persisted for several seconds. The volume of sodium hydroxide used was recorded. The percentage of total acidity was calculated using the formula provided in the article.
Now let's move on to the calculation of percentage total acidity. From our case, the percentage of total acidity was calculated using the following equation, which is percent total acidity equals to titration volume times sodium hydroxide normality times molecular weight of acid divided by sample weight in milligram and times 100. However, from our case, the total acidity has been given, but it is not that it is replicated twice. So, in order to calculate the percentage total acidity, we will have to use the average of the fruit's vinegar. Because there are two replicates, so we will combine replicate 1 and replicate 2 and divide it by 2 to get average. Let's dive into the specific fruit's vinegar calculation of total percentage of acidity. So, moving on to the pineapple. First of all, we will need the volume of sodium hydroxide. So, in order of that, we just manipulate the equation of percentage total acidity to get the volume of sodium hydroxide, which is percentage acidity times sample weight divided by normality of sodium hydroxide times molecular weight of acid. In this case, we use acetic acid and times 100. And then we will get 3.4921, which is the average replicates of the total acidity of pineapple, and times 10,000 divided by 0.1 times 60 times 100, and you will get 58.20 ml. And then, since we have gotten the volume sodium hydroxide, we will calculate the percentage of total acidity, which is 58.20 times 0.1 times 60 divided by 10,000 and times 100, and we will get 3.49% total acidity of pineapple. Next, which is apple. This is the same formula how to calculate the percentage total acidity just like the pineapple. So the percent acidity we got is 3.5939, which is the average of the replicates of apple, and times 10,000 divided by 0.1 times 60 times 100, and we will get 59.40 ml. And then we just put the volume of sodium hydroxide into the percentage total acidity equation, and just like the calculation, and we will get 3.56%. Also the same, just like pineapple and apple, the pair is calculated by finding the volume of sodium hydroxide first. So we will use the average of pair, which is 3.5744 times 10,000 divided by 0.1 times 60 times 100, and we will get 59.57 milliliter. And the percentage total acidity is 59.57 times 0.1 times 60 divided by 10,000 and times 100. We will get 3.57%. And the last fruits vinegar, which is orange, exactly the same calculation. So the average percent acidity of orange, 1.4488 times 10,000 divided by 0.1 times 60 times 100, and we will get 24.17 volume of sodium hydroxide. And the total percentage of acidity is 24.17 times 0.1 times 60 divided by 10,000 and 100, and we will get 1.5%. This is the comparison of fruits vinegar and their percent total acidity. The highest acidity belongs to pear, and followed up by apple, pineapple, and in contrast, orange vinegar showed significantly lower acidity, which indicates a weaker microbial stability compared to the other fruits.
To conclude, this experiment shows how volumetric analysis through acid-base titration is directly applied in the food industry. By titrating homemade fruit vinegar samples from pineapple, apple, pear, and orange, the total acidity of these samples can be measured accurately. The total acidity is a key quality factor that influences taste, preservation, and safety. This study confirmed that these homemade vinegars contain zero detectable ethanol and had acidity values between 1.38% to 7.69%, indicating that the fermentation process was successful. This vinegar is not only a useful condiment, but also a safe, halal-certified product with health benefits. Overall, vinegar serves as a perfect example of how chemistry supports food safety, consumer confidence, compliance with religious standards, making titration an essential tool in both laboratories and everyday life. That's all from us. Thank you for your attention.